Good evening, everyone, and welcome to another edition of the Weather Junkies. It's Thursday, and it's a hot Thursday in Colorado, where I am right now in Meade, Colorado. It's just going to be me tonight and our guest, Zach. Tyler actually got hung up earlier today and is not going to be joining us. Kind of a last-minute thing. It's also part of the reason we started a little late and that we didn't have intro. We probably won't have outro music either. Just a little programming note there. Sorry about the late start. But yeah, it's a hot day in Colorado. Dew points in the 40s, got into the mid 90s. Pretty typical day we're having for this week. Probably get a little bit of rain, some showers and thunderstorms roll through later this evening. But we're joined by Zack Labe, who's a PhD student at the University of California, Irvine, and you got a bachelor's in atmospheric science at Cornell, and now you're getting your PhD in Earth System Science. Zach, welcome to the show, and thanks for joining me today.
Yeah, thanks for having me.
So, how's the weather? I'm assuming you're in California. How's the weather out there?
Right. Well, it's actually pretty hot. The summers out here are different, is that our hotter temperatures are sort of the end of this summer, so we're just sort of getting into our hot season, and I think this is sort of the first heat wave we've had in a few weeks.
Yeah, so how hot is this expected to get out there?
Well, here along the coast, we're pretty close to the Pacific, so it doesn't get too bad, but parts of LA and some of the inland areas will get up into the lower 90s, but it's dry, so it's not too bad until you get into the deserts.
Gotcha. So we'll talk about that a little bit more about your work in a bit, but we're going to talk about a few tweets right now, and I actually picked all tweets that you're probably somewhat familiar with. I actually went through your likes to see what you've been liking recently, because I knew Tyler last minute wasn't going to be on,
Right.
and so I figured you'd want to chime in a little bit if you can. So yeah, feel free to chime in if you want to, but we'll get to the first tweet here. It's from Scott Bachmeyer. You can follow him at CMISS Satellite _satellite. He's a great follow. If you're not following, I recommend it. And he tweeted out, with only 9 days left of 24 hours of sunlight, Barrow, Alaska is stuck between sunlight and darkness. Two reasons I picked this tweet. First, it was in your likes, and second of all, I'm actually going to Alaska on Saturday, and I'm actually really excited to experience what it's going to be like for a daylight for an entire day. I think that's going to be cool. I don't know, probably drives some people crazy that live there permanently, but I'm looking forward to it. Can you tell us what we're looking at in this image? Because I don't know if you know, but I have no idea what I'm looking at. It's visible imagery of some sort.
Right. So I think what's interesting, I sort of liked it because we think of satellite imagery as only looking at things like clouds and things like that, but it's amazing how much we can sort of do with cloud imagery now to take a look at different parameters in different fields. So I like this field that we're taking a look not just necessarily at the clouds, but we're actually seeing the sunlight and the sun's shadow from where it's permanently dark. So I don't know, I like his tweets because they sort of expose different aspects of how we can use satellite imagery to capture different parts of geosciences, meteorology, oceanographic sciences, things like that.
Gotcha. I see what he's saying now. For some reason, at first, I didn't understand what the sentence meant with the image, but now it makes sense. I feel a little stupid now, but yeah, no, that's really cool. You normally the tweets that get the pictures that go viral or get a lot of retweets are like the really high quality ones. But this one's really cool for other reasons than, because it's not the highest of quality image. It's still
right. It's not your typical Himawari satellite image.
Yeah, exactly. So I'll move on to our second tweet here. It's from Bryant's Weather at Bryant's Weather. Apparently he's a Penn State media alum. So that's cool. He tweeted out, "This is also the largest percentage of severe drought in Pennsylvania since fall of 2002, and he tweeted out an image with the percentages since 2000 to now of Pennsylvania that's in a drought. And I hadn't been paying attention that much to the eastern drought since I've moved out here. but yeah, I had no idea that Pennsylvania. There's a large part of Pennsylvania and upstate New York that is under drought right now.
Right.
I'm looking at the.
Yeah, well, I came from Cornell and the Finger Lakes, and they were upgraded to a severe drought just over this past update. And then Pennsylvania, also from Pennsylvania, so I try to keep track of their weather. It's a lot more exciting than here in California for sure.
Yeah, well, I did, and it doesn't look like they're going to get much relief in the next, I don't know, week or two.
No, not at
We got
all.
the.
The excessive heat coming up, probably the drought will intensify across portions of the Northeast. Um,
Yeah, that's never a good sign. I saw someone describe shoot, I forget which publication it was, but they described it as a heat dome, and I thought that was kind of funny.
and a
You
lot of
know,
people have been using flash drought a lot on Twitter this week. Seems to be a buzzword, and I don't know.
huh?
I wasn't really familiar with that terminology before up until recently. They were talking about it in the Great Lakes, how you can go from moist conditions to dramatically drought from excessive heat and dry weather.
Yeah, that's interesting. I did see flash drought a few times, and yeah, I gotta familiarize myself with that. Out in Colorado, we've been real lucky this spring. We got quite a bit of moisture, and just a very few parts of the state are under drought right now, which is great compared to a few years ago when there
Right.
was fires and droughts, and that was terrible out here.
It's really
Um,
interesting to see, drought conditions here in California are much different than a drought condition in Pennsylvania. It can go from moist to a drought in Pennsylvania in a matter of months, but here in California, it's a long process because we have such a long dry season, the Mediterranean climate out here. So it's sort of
right.
different. I think that idea of having severe drought, what that really means is interesting because it's very different from the West versus the Northeast.
Yeah, I didn't. I guess I've never thought about the comparison between the two and how people view them. I guess all droughts are not created equal in a
Right.
sense there.
Right. I keep seeing maps of like soil dryness, and it shows California and Pennsylvania almost having the same, anomaly for being dry. But really, our droughts, California, it's a 5 year plus drought, and we're like receiving 50% less rainfall on average. But in Pennsylvania, it's a much more shorter term drought. Yet, how we quantify the soil moisture, it makes it look as if it's the same.
I don't think I've ever found drought as interesting after you just said that.
There's not much
Yeah,
to talk about in California weather-wise.
that's funny. We'll go on to our next tweet here. It's on a humorous note. It's from Ryan Stauffer. You can follow him at RMS5539. He's a atmospheric chemist and research meteorologist at NASA Goddard, and he tweeted out an image of shoot, I don't know the guy. He's probably someone on
I don't know
Obama's
either.
staff. Probably, yeah, it's probably someone on Obama's staff. But then Obama is in the foreground looking at the an image of temperature, and it's an image of a heat wave in central United States. And he's looking at it, and the guy has a little bubble. It says it's just a model, not a forecast, which is something that people commonly tweet with snow maps and other type of hypey, sensationalized events. And this is referencing Obama tweeted out a similar map of temperatures that were, most of them were like 90s and above, and it said something like drink water, stay inside, which I thought was really cool, by the way, that he did that. I know a lot of people have varying opinions on Obama and his administration, but I thought it was cool that he tweeted something like that out that is important for the public to know.
Right, I agree. I think, we can always improve weather communications, and it doesn't necessarily have to be from meteorologists. I think that they're realizing there's these products from NOAA that they can use is great to see.
Yeah. So we'll move on to our next tweet here. And last tweet of tonight, it's from Gavin Schmidt. You can follow him at Climate of Gavin, and he tweeted out a graph of land ocean temperature index and it's an anomaly since 1950 to now. And the tweet says record for the last 6 months, partly due to El Nino, which has just finished, but would still have been a record without it. And it basically shows three lines, one of which is the 20-year smoothed temperature anomaly, and then you have the ENSO corrected temperature, and then the well, I guess what is the actual temperature processed by GIS, and it shows that even if you take out El Nino, because usually when you have these strong El Ninos, it bumps up the temperature globally, that we would still be a record warm year. Zach, I was hoping you could comment on this, and it's a very interesting chart.
Well, it's interesting. There's a lot of confusion with these global temperature maps because about mid-month this time of year, or this time of month, is when we get all of these different temperature reanalysis data sets, and they all show around about the same thing. So it's all these different reanalysis data sets analyzing global temperature, and the GIS is one of the most prominent ones. And I think the case is that a lot of people are arguing that the El Nino had such a warm influence on the globe that that's why 2016 would be the record warm year. But what these maps like Gavin Schmidt posted are, and a lot of other climatologists are showing that our temperature trend, not including the influences of natural climate variability is increasing so much. So we're having these record warm years even with the additional effects of El Nino. So we're having this temperature gradually increase, and then you have these gentle nudges for periods of time where sometimes it's even warmer than the average trend, or sometimes it's cooler. So I think this plot was a perfect example of, even though without the influence of the warm El Nino, we're still on a gradual increasing trend globally.
I can't wait for tons of people to argue that we've been cooling since 2016 in the next few years. I can just see that coming, like 1998 all over again.
Right, and I've had to laugh because a couple months ago, there was arguing for us to transition to a strong La Nina. And for those not familiar, that's sort of the opposite and more of a cooling effect it could have globally. That's what they were arguing. And now we're seeing the La Nina sort of much slower to develop. We're seeing the statistical models sort of back off in the intensity. So it's going to be interesting to follow the global temperature patterns over the next year to see sort of how it responds to a post-El Nino environment.
Yeah, that will be interesting. And I'm sure we'll see some tweets from you and others about that, and endless articles about it. But let's get into our main topic of the night, and that is Zack Labe and his research. Zack, this is kind of how we always start one of these conversations. Just want to get a background on you and how you got into the atmospheric sciences to where you are now.
Sure. So I originally was interested in all weather. Growing up, I was just like you and everyone else. I can't say I don't know why. One day I started really becoming interested in the weather, but sort of always have since as young as I can remember. So anyway, I knew I wanted to go to college, to undergrad, for meteorology, and I thought for the longest time weather forecasting is sort of what I was interested in. And through undergrad, I went to Cornell in their atmospheric sciences program, which is it's a smaller program. It's very research-driven, not necessarily forecast-driven. So I think perhaps that might have been influenced sort of how I changed routes. So anyway, about halfway through Cornell, I talked to a professor and started research with him. And it had more of a sort of climate influence. We were analyzing climate models and their predictions for the timing of spring and how that would change in a warming climate. And I really became interested in climate change, sort of going through this research and seeing, to me, reading the literature and understanding the actual facts on climate change, it seemed so obvious what was going on that up until that point, I understood it to be more controversial, and then I realized this is not controversial. There's a lot more science and literature going on. So I thought, this seems so obvious to me. How can we better communicate climate science to the general public to realize that it's not controversial, it's not political, it's actual, a theory that's been thought out for decades, 100 years, the greenhouse effect. So I continued with the research and realized I'm not maybe quite as interested in weather forecasting sort of as a career path, but more a hobby. And then started grad school. Actually, I'm now going on 1 year here in Irvine. And my program is Earth System Science, which is a little different than other programs. So I came from a meteorology program, but Earth System Science, we don't isolate one Earth sphere. We try to combine them to understand the ocean, the cryosphere, the atmosphere, and how they interact. So I like to think of it more as a climate science degree. And my research here is more atmosphere-based in the climate field, sort of looking at how changes in the Arctic, which are changing faster than the rest of the globe, are responding to climate change, responding to natural variability too, and how possibly they could affect weather patterns, like here in the mid-latitudes. So it all sort of comes back to weather and my interest there, but it's certainly diverged along the way.
Wow, so a few things there. I actually visited Cornell when I was looking for colleges, and if I were to pick a university to go to based on the surroundings and the environment and how pretty it was, yeah, Cornell would have been it, shoo-in. I actually didn't apply. I probably wouldn't have gotten in, but yeah, I just wanted to comment on that, and I wanted to give a shout out to Cornell Weather. I'm sure you were a part of that group, but they followed us and gave us a retweet the other day, and so I just thought I'd give them a little shout out. One other thing, so before we get into kind of your research now and how you got here, I was curious about the forecasting part of it. Do you still do any of that, like for a hobby or I don't know. It sounds like you enjoyed it as kind of that purpose as a hobby and an interest. Do you still kind of dabble in that at all?
I started with it on Weather Underground back, I guess like late 2000s. And I started a blog on there. Have you visited their blog site? It's not used.
I was there before.
Yeah, it used to be really popular. That was one of the first sort of weather forums outlets there were. And, one day I just decided, I love forecasting weather. I'll write about it on a blog, forecasting for like the Northeast, just for snowstorms, thunderstorms, things like that. And I started really growing a following, and it was great to interact with all these other sort of weather nerds that I didn't know existed up until that point. And I used to write these crazy long blogs for years, and then, college hit and just too much time. So I don't actively forecast anymore like I used to. I loved Weather Underground. And now I'm sort of seeing Twitter. I just sort of joined and became active within the last year. And Twitter is nice because I don't have to write like a 10-paragraph blog that takes me hours to write. I can just quick see something or think something, attach an image, and tweet it out and get hopefully people to interact with what I find interesting. So it's I can do it within minutes instead of taking all day. So now, unfortunately, I hope one day to write weather blogs and things like that again because I like it, but it's time consuming.
Yeah, I didn't know you were on Wonderground. I saw that you had a few blogs on your site, but wow, this is really cool. I'm reading one of them right now, and yeah, it looks like you do have quite the following. That's impressive.
Yeah, I was on their featured bloggers with Dr. Jeff Masters. So I was up there for, I guess I'm still posted there, but I don't update it very much. But I used to post a lot, and we would get like thousands of comments every week during big winter storms to hit the Northeast. I guess sort of my peak weather forecasting was when Snowmageddon hit. And all. So a lot of people were attracted then because every week it was a huge snowstorm. So it was super fun. I loved interacting with people. And a couple of them have found me on Twitter now, so it's neat to see them again.
I'm going to have to dig up the Snowmageddon one because I was in that, and I would like to see your forecast on that.
Old snow maps. I forget if they were awful or whatnot.
It's always fun to dig up people's previous forecasts.
Yeah, Microsoft Paint.
Yeah, we've all been there. Well, it's really cool. Wow. If you go to Wonderground blogs, wonderground.com/blog, you're the third blogger to pop up under meteorology blogs. So yeah, go check him out. Go check out his past blogs if you want to see what he's written before. So on to kind of what you're doing now in your work as a PhD student at UC Irvine. I guess I wanted to lay kind of a foundation for this conversation and talk about first the difference between climate models and weather models. And I'll preface it with I commonly hear people saying, I'm playing devil's advocate here, by the way.
Sure.
Commonly hear people say, how can we predict the future climate if we can't predict tomorrow's weather? What is your response to that?
And I think this is a miscommunication, not even just with the public, with meteorologists, professional meteorologists. It's that there's fundamental differences between climate models and numerical weather prediction. Climate models are sort of developed to understand the physics of different spheres in the atmosphere. So how do the oceans work? How does the cryosphere work? How does the atmosphere interact? And it's designed to work on long time scales. So climate models can't really detect particular events, but they can understand trends over periods of time. Where weather models are developed in a different fashion, they're built similar to climate models, but they're designed to understand different events, and they do not respond to these long-term trends that we see in climate models. So adding, CO2, doubling CO2 in a numerical weather prediction model is not going to have an effect on your weather forecast. So comparing climate models and weather models is definitely a misnomer. You can't compare them. And even sort of models like the CFS, which understand that it's sort of a longer-term weather model. I see people try to argue, use the CFS as a climate model, but it's different than having a global climate model that understands these interacting parts. So it's definitely something we need to get across, that there are fundamental differences between the two.
Yeah, that is an awesome answer. Perfect response to that. And because it was such a good response, I'm going to play devil's advocate once again. I also hear, I guess not a lot of people, but I do hear it. I hear them say climate models aren't good enough to influence policy. Would you say that climate models are good enough to influence policy, and why?
And I think they are. A lot of people don't understand, but there's a huge amount of statistics that go into the climate models. When their climate models developed, they produce something called a hindcast. And what they do is they try to extrapolate using the climate model to forecast and compare it with what happened in the past. So they try to compare how well the climate model thinks, for instance, 1950 was versus what actually happened. And that's sort of one method of verifying how well is the climate model producing large-scale atmospheric climate effects. So then when they run it into the future, they have different scenarios, and these scenarios are based on a lot of different things. Some people think the scenarios is just changing the amount of carbon dioxide that we input, but these scenarios account for all different things, like changes in population size, other anthropogenic effects, natural climate variability effects. So they run different scenarios for the future so we can sort of get an idea of the range of outcomes that might be produced for our future climate. So I think we can interpret these range of outcomes, not with certainty. Like, I'm not saying in 2100 it's going to be exactly 5 Kelvin warmer, 5 degrees Celsius warmer than it is today, but we can get a range of maybe what the temperatures on average across the globe will be. And that's really important to understanding changing climate when we look at policy and how we're going to adapt in the future to these changes.
So yeah, I wholeheartedly agree there. And I want to get into some of the work you're doing now. Before we do that, Dominic Ramuni, one of my friends from undergrad, just chimed in and said, I was one of those Wonderground followers way back when. Really enjoyed your success these past few years, Zach.
Oh, so, great. I wonder what his name was. One Weather Underground. Blizzard 92 is my name.
Oh, okay. Yeah, I wonder what Dom's is. His Twitter handle is WeatherDom, so it might be something like that. So you use a climate model, or I guess you use more of a Earth system model to do some of your work. What is that model, and what are you doing with it?
Well, I'm finishing up work from some of my undergraduate research. We submitted a paper, so we'll see what happens with that. But it's an interesting project. So what they did is they took one of these fully coupled climate models. So fully coupled meaning they have interacting parts between the ocean, ice, the cryosphere, the atmosphere, the land, and how they interact. And what they do is they run ensembles, and a large ensemble envelope is essentially they take the start of the model and they tweak the initial conditions in each ensemble by just a little bit. So you can think of it as a butterfly effect. Just a small change in each ensemble has a big difference in the outcome at the end of the climate model. So when they ran this, it's called the CESM Large Ensemble Project. You get all these different ranges of outcomes from each ensemble, still based on the same physics of the climate model, just by tweaking them a bit. So I can understand sort of what the range of outcomes for these predictions might be. And then we can also take the average, having that many different ensembles, that many scenarios. By taking the average, you sort of get rid of some extraneous outliers that might exist. So I think sort of the trend in climate science is going away from using just one model, but using ensembles where we can get this range of scenarios, we can take the average of them, we can see the maximum, the minimum, and it's giving us a lot better of an idea of what the possibilities are in the climate, rather than saying it's going to be X and Y. We give a whole range.
So for those of you that might not be familiar with CESM, a good analogy for it is it's like the Python of models, because you can download it, you can run it yourself, and then if you find something interesting that you put in the model, you can suggest it, and then it'll be reviewed, and if it's if it's a good suggestion, they'll incorporate it in the model. And I think that's what makes this model so powerful. It's housed at NCAR and UCAR in Boulder. And there's so many contributors to this that it makes it easier to improve because it's just not one group or team that's working on it. So I saw I was looking at your site and I saw a poster of yours that I think you presented at AMS or AGU, and you were examining March 2012 and the early onset of spring. And I was just curious if you can explain what you did there and what you found by examining these types of events in CESM.
So we tried to take, 2012 was a really, really warm spring in March. But another problem with that year is that anomalous warmth that was so early, it allowed all these plants, all these agricultural crops to bloom. So you have all these trees, these plants blooming across the Midwest, the Great Lakes, the Northeast. And then temperatures fall back to normal in April, and you get colder weather and frost. So you had a lot of agricultural losses. They topped, in the millions, especially across Michigan. So when we're looking, we know the Earth's climate is warming. So we want to try to understand, is 2012 an anomaly? Or is this something that might be happening more likely into the future? So the project was using output from CESM, particularly temperature data. And then we used another model, which is this model that's based on phenology. So phenology is basically looking at plants and sort of how they respond to temperatures. And the model we looked at was called the Spring Indices model. So you input temperature into this model, and then you get an output of when the model thinks spring is going to occur. So as temperatures continue to warm and warm, then eventually the plant will bloom. So it's sort of an accumulation index. So what we did is we took the data from the CESM climate model, and then we put that into this spring model to see through 2100, are we going to see years like 2012 more frequently? Because it's important for agriculture, for energy, and a lot of different other sectors out there.
Yeah, so I thought it was really interesting how you phrased your future work. You made it in a sense that it would be profitable and advantageous for farmers and insurance companies to know about this. And I think that's a great way to put it, because if you want your research to get noticed or to be useful to someone, you kind of have to give them a reason to pay attention to it.
Right, exactly.
And so I'm curious, did you find that these anomalous springs, this early onset, was something that you found that is going to happen more normally in the future, or was it inconclusive?
Right. We actually found a very strong signal, and it's sort of also there's another paper by Andrew Allstat from University of Wisconsin, and they did a similar project looking at the timing of spring, and they also found results similar that the timing of spring is becoming earlier and earlier, particularly by mid-century. It's almost, you go over this ledge by like 2050, 2060, and now we're seeing across the areas like Great Lakes in the central United States, spring from the model output is now happening 30 days earlier than it is on average today. So we need to figure out how can agriculture and other sectors sort of adapt to these kinds of changes. So yes, our results support that springs like 2012 may become a lot more common in as little as 30 to 50 years from now.
And so that was like a very specific thing that you focused on with CESM. Is there anything that you're looking at now that's specific? Maybe an event or something that you're looking at now in your work?
We're kind of switching gears now to the Arctic. So my projects now are kind of completely different than what I did with the spring work. So now we're taking a look at sea ice and how sea ice might have an effect on the climate, which is definitely sort of a controversial idea right now, is how Arctic warming might affect or might not affect the weather patterns across the mid-latitudes and such. So right now I'm taking a look at the thickness of sea ice, which might seem arbitrary, but we don't really know a lot about sea ice thickness. We have a lot of satellites that go across the Arctic, and when they're looking down in the Arctic, they can see how much sea ice is there, but you can't see how thick the ice is. And we know that the thickness of sea ice has an important part in the amount of heat that's exchanged between the ocean and the atmosphere. So it's important to quantify how much sea ice thickness, how much volume is actually sitting there in the Arctic. And right now our observations are fairly limited, particularly in time. The measurements we do have are just as of the last few years for the most part. So my project's now trying to better understand sea ice thickness and what's up there. And with those results, we then hope to, after we better understand the thickness, we hope to input that into climate models, which often just say thickness is one amount. So they're not accounting for any change in the Arctic, which is kind of crazy to think about. So by changing it, using our results, we're hoping to see if there's an atmospheric response.
That's a very interesting and super important subject right now. I read a paper by Melissa Burt and David Randall about dark warming and how there's this positive feedback that people hadn't paid attention to nearly as much compared to the albedo positive feedback. And it's very, very important for the future of our climate system. And I've noticed that you have tweeted out, you tweet, is it daily that you tweet out the Arctic ice?
I tried changing. 2016 is a particularly interesting year with Arctic sea ice. So
yeah, I was curious. Could you touch on that, where we are right now, and I don't know where you think we're going to end up in terms of we're at an all-time record low, correct?
Not anymore, actually. So there's some misinformation about the condition of the sea ice right now. So for practically all of 2016, we've been the lowest amount of sea ice up there in the Arctic. It was an extremely warm, the warmest winter across the Arctic Circle on record, and to respond to that crazy amount of warmth that was up there. But then the weather patterns have changed in June, so we actually saw kind of more favorable conditions for ice. So that's allowed the ice, the melting amount, to sort of, the rate of change has slowed. So now we're not quite at a record low, but that doesn't mean everything's okay. There's certainly, looking at the status, the condition of the ice, it looks really poor, and we still have a lot of weeks to go before we reach the annual minimum of the amount of sea ice up there. So it's going to be interesting to see. I'm pretty sure we're not going to see a record low like 2012 this year. We just didn't have that melting momentum we needed in June. So I know there's been a lot of articles on Twitter and such about, this is going to be the new record low, but You can't say for sure, but I think as time goes by, that the probability of a new record is decreasing.
Oh, that's good news.
I
I think I
guess.
just saw I think I saw the graphic so many times and it was record low that I just kind of assumed it was still. But yeah, I'm looking at it now and you clearly, yeah, it's
It has,
not as
yeah,
bad
it's
as
been record
2012.
just up until the last week or two. So,
Gotcha.
but it's very close to the record low. So it's hard to compare it to really. But I posted a tweet today that I really think represents everything in one graph of what's going on in the Arctic. And it's the idea of how much it's thinning over time. So the figure's pretty simple. All it shows is a different line for the average sea ice in the 1980s, the 1990s, the 2000s, and where we are today. And you can see just from these three lines that the average is slowly and slowly becoming lower and lower as time goes by. So sea ice, it's not that 2016 is some strange anomaly. This is something that's been happening over time where we're having less and less ice in the Arctic throughout the entire year. And I think it's really evident in this plot to see that change.
Yeah, this is an awesome graph here. If you're not looking at it, check out Zach's Twitter profile at Zlabe. So this is something actually I wanted to talk about. You make some of the best weather GIFs, images, whatever it's charts, plots, whatever it is. You
Oh,
make some
thank
of the
you.
best. And so I want to know when you're going to do something like this, what are you looking for? And yeah, let's just start there. What are you looking for?
I think my side interest from climate and weather is science communication because there's so many times I see what I consider and a lot of other people poor plots, both in journal publications, plots for the public. And it's not just the colors that are chosen, it's all sorts of things. So when I go to make a plot, I want it to accomplish a couple different things. I want it to be easy for the public to understand. Because science, why are we doing science? We're doing science to not only improve science, the field, but we're trying to improve society, our understanding of everything around us. So when I do plots, I want to make it so everybody can try to understand, what the plot is showing. So I try to make it simple. I try to pick colors that might be more appealing and not necessarily misleading. Lately, I've been finding that having sort of a black background and then white font is really effective for the eye. It's much easier to sort of read, so a lot of my plots have been sort of designed that way. And I think it's something in meteorology where we use maps all the time. It's something we really need to improve. Sort of, what are our maps showing? What unnecessary information is on the map? And things like that.
Wow, that is I love your thought process there. It's a can of worms, but I love
Right, of
the
course.
improving science communication. I mean, that's very important in climate and weather right now. And maybe I'll send you my thesis to look at to look over my graphics. Um, so we're coming out on the 45-minute mark here, and we ask every guest of the show this question, and that is, if you were to talk to someone who's in high school, college, looking for a job, looking to get into grad school, what has been the most important skill in your education and your research career, and what kind of advice would you give them?
I think it's been getting to know a lot of people in a lot of different fields. I think looking back on my undergraduate experience, the best part of it was not just staying with science people, but I had friends in all different aspects of everything, from journalism to veterinarians, to biologists, to artists, to architecture people. So it's getting to know a lot of different people with a lot of different ideas and finding people that are passionate about those different fields and just listening to them about their passion. I think that's kind of, it gives me good ideas. Listening and talking all day to science people can get old pretty fast, as you know. So it's nice to hear, a different perspective, like in English and the liberal arts, something, radically different. It gives me lots of new ideas, how to improve what I do and just experience different things.
Yeah, that's great advice. You don't want to make a an echo chamber for yourself because
Right.
it can never be good. So thanks so much for joining us. That it was a great conversation, and we talked about a lot. But I think it was great. So thanks so much for joining us, and
Yeah, thanks for having me.
yeah, we'll have you on again sometime
Yeah,
if
sure,
you
that's
want to join us
anytime.
again. So if you're not following us on Twitter, you can follow us at the WX Junkies. We're also on Facebook. You can listen to this podcast on SoundCloud, YouTube, iTunes, or Stitcher. And if you're listening on iTunes, go ahead and give us a rating or review, just so we can hear from you. And next week, I actually won't be on the show. I'll be in Alaska for the week, but we will be airing our second episode of Weather Ready or Not. So Tyler might have a few comments before that. So if you're around, come back here Thursday at 8 p.m. Eastern, and we'll be here. Thanks for joining us tonight, and we'll see you next week.